Hey everybody, this week it's lessons learned. We're talking about a couple things that I've learned over the last couple of months here with the solar systems and an update. So I'll get the update out of the way quickly here. I've got my actuators. I got another one coming to replace one of the actuators for the sets of panels. So to give you a quick recap, the panels are put together in a grid of 4 and 2. I framed them myself. Everything is DIY here. I've got it hinged at the top with a pin that goes through and into the frame, which allows me to swing them at any kind of angle from 0, in theory, up to 90. I can move it myself in any of those spots. The actuators will be what's the limiting factor for that. Here in the Northeast, where I am, the projections are about 23 degrees up to about 63 degrees. So from dead of winter to high summer, so my min is 23 and my max is going to be about 63 degrees. And that's taken from the angle of 0 being completely vertical, 90 being horizontal. So it doesn't have to go all the way up to 90, and it doesn't have to go flat. So over the winter I had it flat because it was convenient and I didn't have the actuators in place yet. So I just locked them in place there. And power over the winter was so-so. I went out, they've got to be at the 53 mark right now. They aren't quite there. Once they're close, they're around 50 degrees. And my 600 watt system on a good day is pulling 500 plus watts for 6 inexpensive EcoFlow panels that are now a couple of years old and have been through a couple of seasons. So I thought that was pretty good. You know, we're still getting good power out of these panels. I went that way for a couple of reasons, and the main reason is I can, in theory, if it works, I can pop a panel out and replace a panel, and they're a lot less expensive and a lot lighter to do a single 100 watt panel than would be do a 400 watt setup. It's also smaller, I believe. Well, about the same surface area. But the lessons I learned from that is it's very important to get those things at the right angle. And 90 to 100% almost of the things that are out there aren't adjustable. I mean, you see some big grids out there that have some adjustments to them. If you looked at the Ambition Strikes channel, they've got one set that moves. I think they've got other sets that are stationary. And that's okay. But again, you want the panel to be directly in line with the sun. So if you mount it to your roof, it's not going to work. It'll get sun based off of the angle of your roof. My pitch is a 14 degree down pitch. So you take 14 off of 90, you're talking about a 86 degree pitch, which is too high for the highest point that it's got to be in the year and absolutely useless come winter. Because the sun's going to be hitting it at such an angle that it's going to get very little sunlight hitting that panel come winter. So if I mounted an array on my roof, I would get power over the summer partially. I wouldn't get as much power as I could, and that'd be it. The only way to get the things to work correctly would be to actually move them in such a way that they are hinged upward. And once you start doing things like that, now you can get wind at the back of them. And we've had some pretty good windstorms through here. And the last thing I want, I'd have to go up and lock them down, but you don't want to be away and have a 20 mile an hour wind hit these things when it's just holding onto your roof. So I get why the roof ones are set up that way, and I also understand why roof ones are not the best way to go. Now, the downside for what I've got is because they hang vertically, or could hang vertically, if they're near a window, which one of mine is, it blocks the view. I mean, that's the downside to it. If they're down in the 20-degree range, you're going to lose some view. Not being attached to the house directly means that if the wind comes through, the most it can damage is the porch that it's connected to or the deck, and it can't damage the house itself directly. So the advantage of having it out like that, I'm also going to put up the solar grid that tracks the sun, but that's going to be mounted above ground, way above ground. Typical configuration for it is to mount it into concrete. I'm going to be mounting it into 4x4s with a platform on top of it, bolted the whole thing together, and framed around it to keep the 4x4s from having to take the full brunt of any wind blowing side to side. In theory, it can lock down itself into a situation to prevent the wind from damaging it, so we'll see how all that works out. The advantage of that type of unit is it can track morning to afternoon. The panels that I have right now are good dead south, so they're good for a couple of hours around noon based off of the pitch that I've got them at, and they'll be good for a couple hours around noon. The sun transits the sky. This other one will follow the sun to try to keep that sun square onto the panels. So that should give me some more power. I think that's a 600 watt configuration that I've got set up there. I will lose some if I set them up all in series. So I haven't quite decided what I'm going to do yet. If I go parallel, then the fixed panels, semi-fixed panels, won't be taking power out of the setup. If you're used any solar panels, you're going to be aware that the shade on one panel, when they're in a series, can impact the power out of the entire unit, right? It's not just taking one panel out, it's impacting everything. So I got to figure out which one I want to go there. I don't want the sun tracker to lose power coming in. On the other hand, I don't know if I want to put it in parallel with the one that's there. The units that I've got, the setup I've got, works either way. I can easily run another line down and hook it into the main box and be good from there. The other lesson learned that I got, one of the things I had thought about early on was, can these units be used to back up important electronic equipment? And the answer is yes and no. All of them can to a certain extent. Some are better than others. Like the Delta Pro Ultra that I've got has just about an instant cutover, so you don't notice the change in power. The Delta 2 that I've got doesn't work that way. So I thought one way around something like that would be to put a battery backup unit in place, right? Attached to the device, and that device would power the battery backup when the battery starts to go down. It'll be getting power from the main unit, and then we've got a reserve. So think of it this way. If the battery backup unit you've got is good for 2 hours, and the unit's attached to is good for 8 hours, you get 10 hours, because when the first unit goes down, when the 8-hour unit goes down to its 30% or whatever you've got it set to for the floor, and it turns off the AC, then your battery would kick over. Seemed like a reasonable setup for me. What I found, however, is my Delta 2 doesn't have power coming in at all times. So my configuration is I have a Delta Pro Ultra with 12 kilowatts worth of power in it that's connected to my outside grid. I have a Delta 2 that's connected to the Delta Pro Ultra to get pull power if it needs it, plus it's connected to the outside to a 220 watt bifacial Renogy panel that I've got, which is currently just laying flat, so I'm not getting any advantage from it being bifacial right now, but that pulls power in and starts to recharge that Delta 2. But if I have the Delta 2 not getting power from the Ultra, the APC unit that I've got doesn't think there's any power coming in, even though the AC's on, even though other units are running off that Delta 2. The battery backup unit thinks there's no power, and so goes into, okay, I've got no power, I need to shut down mode. So my scenario that I talked about, the 10 hours getting 8 and 2, I won't get that. The most I can get is 2 off the battery, because the other 8 isn't going to get used because the battery doesn't recognize that it's there, which is annoying. If, however, there's power coming into the Delta 2, so if I tell the Ultra to power up the Delta 2, that will let the battery know there's power and everything's fine, which makes no sense to me. There's something about the way the battery is getting its power, and it might be the way the Delta 2 is set up. Like I said, the Delta 2 doesn't cut over immediately to power. And I'm wondering that if it's off, if it doesn't, the battery doesn't think there's power because of the way the unit itself is designed. But even if everything else is getting power off of it and the Delta 2 is off power, it should still work, but it's not. So that's an interesting lesson that I learned from that. I'm not really sure the electrical criteria that's not meeting, that's making the battery think that it doesn't have a connection. I'll leave that up to any electricians that listen to this that figure out why that would go into that state. So you get the flashing power light on it. It's just a little 450. It's not a big unit, but it gets that flashing light on it thinking it's got no power. As soon as the Delta Pro Ultra kicks in and is giving power to it, everything's fine. Even if the Delta Pro Ultra is just connected, but the unit isn't picking up power from it, it still works, which is what there's something about that connection that it's looking for, the connection from the device to electricity that it's looking for to keep the battery thinking everything's good. So in theory, if I've got the Delta Pro Ultra feeding this, which is feeding the other, then everything should work as I thought. You know, we get 10 hours there, plus it'll be pulling from the Delta Pro Ultra, so I'll get the 12 kilowatts worth of time there. I'll have a lot of power going to this little router that I got connected to it. But it's not working out exactly the way I wanted. And I've just got a little Wi-Fi router on there just to test it out and see how it was working. And this is what I discovered from it. I originally bought the 450 to run my Ender V3, which shouldn't be pulling as much power, but between the Ender V3 and the dehumidifying heating unit I've got connected to put the spool in, it's enough to cause that thing to spike on a 650. So, you know, it shouldn't have been. It should have spiked around maybe 400. And with that and the other unit, it's spiking well over 650. So that's what I learned on that configuration. Now I put my, I think I talked about this before, but I put my 3D printers on battery backups because the power here, they're replacing the copper wiring for the electricity. And as they do so, they've got to cut over from one to the other and we lose power for a brief amount of time. Well, it's enough for the devices to get quick on and off, which is not great for them. So by putting these things on battery backups, they don't notice the power glitch at all. And if the power were to go out, that also means if I left any of them on for some reason, I can go and turn them off before they actually will lose power so they can have a nice normal shutdown. But the battery thing was the weirdest thing that I've run across so far on the whole solar setup. With my 220 up there, I've been pulling about 160, 180 watts off of that, being at a bad angle. And the other one's pulling me 500, so I've got almost 700 watts coming into the house right now out of an 800 watt system. So that's not too bad. The other panels, I got two panels that I've used before that'll go up. And last year I had a couple on the roof facing east and facing west, so I could pick up a little early morning sun and a little afternoon sun to get a couple of extra watts in. They were two 100-watt units that were there, and one of them became my 200-watt unit that I created. But I've got 4 brand new panels to go up into the other unit once I get that all in place. So again, the idea for that, for those interested, is 9 4x4s. Now, if you're familiar with a 4x4, they're not 4x4s. They're 3 7/8 or 3 3¾ something like that. So they're not quite 4 inches. So by putting the 9 of them together in a block, that should give me enough space for the base to go in. Those being tied together and the unit being bolted into those 4x4s will give me a good solid base. 4x4s are going to be 8 feet up and 4 feet into the ground, into concrete. So there should be enough there to protect everything. And because it's not going to be just left like that, it's going to have a porch framed around it, or a deck framed around it. That's going to allow the whole system to take the weight of any wind blowing. It also means that I can easily assemble it because I'll have a platform 8 feet up all the way around it that I can go in there and attach all the pieces in, get to my panels, replace my panels, and the unit obviously is going to need power. So I'm going to have to run a line into the house for power for it so it can get its electricity. Runs off of 12 volts that needs the power to move the panels. So hopefully it brings in more extra power by moving than the power cost of it moving. So we'll see how it goes. It's a 2 actuator system, which allows it to go all the way from east to west, and at the same time go from, I don't know how flat it goes in either the 0 or the 90-degree range, but it can move from the 0 to the 90-degree range. So it's got some mobility to it to track the sun. For me, with the trees that I've got on to the forest behind me, it won't give me as much in the morning as I will probably get in the afternoon, because tracking to the other side, the trees are a little farther away on the neighbor's side there, so I think I get a better shot of sun in the afternoon coming from that direction. But that's the updates I've got for you this week, and I will talk to you all next week.